Hello, Class 9. This is your second chapter. Is matter around us pure? You have seen that I have written over here pure substances. What does it mean? What is a pure substance? A pure substance means it contains same kind of particles. It contains same kind of particles. Now these particles can be atoms also, or it can be molecules also. So for that reason I can say that they can be elements as well as compounds. Okay, so that is a pure substance, elements or compounds. Now here as an example, if you see, sugar is a pure substance, whereas soil is an impure substance. Why is it so? Why sugar is a pure substance and soil is impure? Sugar is pure because sugar contains only the particles of sugar. Whereas in soil, it is not only the particles of soil, but it contains clay, it contains grass, it contains some insects in it, maybe some pebbles in it. So it contains various things. So matter around us can be of two types. One is pure substance, the other is mixture. Now, pure substance can be elements and compounds, whereas by mixture, what do we mean? It contains more than one kind of particles or atoms, that is a mixture. So here let us see that all the elements and compounds are pure substance. Here, all elements and compounds are pure substance. So, this is what I have written it here. Elements as well as compounds are pure substances. Now what are mixtures? A mixture is one which contains two or more different kind of particles. It contains two or more different kind of particles. It can be atoms or molecules. So a mixture contains two or more pure substance mixed together. So we can say gold is an element, it is a pure substance. Sodium chloride is a compound, it's a pure substance. But jaggery is impure substance. Okay, if I say syrup or sharbat, sugar solution or any fruit juice, they are impure substances. They are not pure substance. Why? Because it is not made up of only one kind of particles. So matter can be subdivided into pure substance containing only one kind of substances or particles, and mixtures containing more than one kind of substances present in it. Pure substance can be elements and compounds. Impure substance or mixtures can be of two types. One is homogeneous mixture, the other is heterogeneous mixture. Now, what is a homogeneous mixture? If I say homogeneous mixture, homogeneous means containing same kind of particles. The term homo over here means containing same kind of particles. This is same kind. Whereas heterogeneous means containing different kind of particles or different type of substances. Another thing I'll say, homogeneous mixture contains uniform composition throughout. It contains uniform composition throughout, whereas heterogeneous mixture contains non-uniform composition. So let us study in details little bit about it. What is homogeneous, what is heterogeneous, and what are the properties. So here are, before we discuss elements, we should know the meaning of three terms. What are these three terms? Malleability, ductility. These are the properties, okay? Ductility and brittleness. Now, does it sound something familiar with the properties of something which we know as metals. Yes, metals are said to be malleable, is said to be ductile and brittle in nature. So what are they? Element is a substance which cannot be split into two or more simpler substances. That is, we cannot break it to any other substance. We cannot use any other chemical methods, say by application of heat or light or electricity, and we cannot split it into any other simpler substances. Example, copper is an element. Why? Because it is made up of atoms of copper only, and you cannot break it down. Okay, you cannot break it down. Now over here, iron. Iron means it contains only Fe atoms, only Fe atoms. So nothing else. But when I say here, say sodium, contains only sodium in it. Chromium contains only chromium in it, chromium atoms. Mercury will contain mercury atoms. Oxygen will contain oxygen atoms. So these are all elements. Now, if these are elements, then it can also be divided into, say, metals, non-metals and metalloids based on its properties. Metals are what I said, malleable, ductile, and it conducts electricity. So metal is an element and it has these properties: malleability, ductility, and conducts electricity. What is the meaning of malleability? Let us see in the previous page. The property which allows the metal to be hammered or beaten into thin sheets. You can make thin sheets. That is the reason that you can make ornaments out of gold. Ductility means it can be made in the shape of thin wire. Same thing I will say, gold and silver, which is used to make ornaments, copper for copper wires. Okay, so ductility. Brittleness means it breaks down. That is called brittle. But the property of brittleness is what? It is not of the metals. This is basically of the non-metals. They break into pieces by hammering. And this is what we will see in these properties. Metals are malleable, they are ductile, and they conduct electricity. And some of the examples of metals are iron, copper, aluminium, zinc, silver, gold, platinum. These are all metals. Magnesium, say mercury. Mercury is a liquid metal. Okay. Antimony, bismuth. These all are metals, fine, but they have some properties which is of metal and some are of non-metals. So these are known as what? Metalloids. So let us see what are the properties of metals. Metals are malleable in nature. They can be beaten into thin sheets. Then metals are ductile, so they can be drawn into the shapes of wires. Metals are good conductors of heat and electricity. So silver metal is considered to be the best conductor of heat. Copper and aluminium metals are also very good conductors of heat. Okay, now cooking utensils and water boilers, they are made up of copper. Aluminium also, because they are good conductors of heat. Mercury is a poor conductor of heat. The poorest conductor of heat among the metal is lead. Okay, so lead is a metal and mercury is also having poor conductivity. Okay, so these all are having poor conductivity. Silver metal is the best conductor of electricity. Copper metal is also a very good conductor of electricity, followed by gold, aluminium and tungsten. Electric wires are made up of copper and aluminium. These are the metals that are good conductors of electricity. So these part are important for MCQ type of questions. Okay, metals are shiny in nature or lustrous. They can be polished also. Metals are generally hard. Okay, so they are not soft. But can you name metal that are soft and can be cut with a knife? Alkali metals like sodium, potassium, they are soft metals and they can also be cut with a knife. They are so soft. Metals are usually strong. They have high tensile strength. That means what? You actually cannot break them easily. Okay, they are very strong. So due to this, iron metal is used in the construction of bridges, buildings. The main framework of construction is iron. Metals are solids at room temperature, except what? Mercury, which is a liquid metal. Now, metals like iron, copper, others are also there, but I have highlighted iron, copper. They are solids at room temperature. Mercury is a liquid. So there is only one metal, that is mercury, which is liquid at the room temperature. Now, metals generally have high melting and boiling point. Okay, so they are having high melting point and boiling point. That means they are very closely packed. The interaction between the metal particles are quite strong, for which they have high melting points and boiling points. And due to this close packing of the metals, their densities are also quite high. Now, sodium and potassium, they are soft metals and so they have low densities and they are light metals. Metals are sonorous. Sonorous means they make sound, they produce sound. You have seen the bells in the mandir or the bells in your school, they make sound, right? Why? Because they are metals. Metals usually have a silver or gray color, except for copper and gold. Moving on to nonmetals. Non-metal is an element again, but it is not having the properties of metals. Obviously, it is not malleable nor ductile, or it cannot conduct electricity, because these were the three main properties of metals. So what were the three main properties of metals? Metals were considered to be malleable, they were malleable, they were ductile, and they were good conductors of heat and electricity. They were good conductors of heat and electricity. So obviously non-metals are not having these properties. Some of the non-metals are what? Carbon is a non-metal, sulfur, phosphorus, oxygen, hydrogen, nitrogen, chlorine. These all are non-metals. And the noble gases, argon, krypton, xenon, neon, helium, they are all non-metals. They are having non-metallic character. So if you have noticed the periodic table, you will see that the elements on the right hand side of the periodic table, so they are, if this is the periodic table, then elements on the right hand side, they are basically non-metals, and the elements on the left hand side, they are the metals in periodic table. Okay, so krypton, xenon, radon, these all are non-metals. Diamond and graphite are also non-metallic in nature. Diamond and graphite are non-metals. Now they are the allotropic forms of carbon. Someone can ask you the question, name the allotropic forms of carbon. So what are they? Diamond and graphite are the two allotropic forms of carbon. So they have carbon in it, but their structures and properties are different. Okay, so mostly the non-metals are solids or gases, except for bromine, which can exist in the liquid phase as well at the room temperature. Okay, so bromine is existing as a liquid phase. It is a non-metal at room temperature. So next, what were the properties of non-metals now? Not malleable, of course. Not malleable. Cannot be beaten by hammer. Not ductile. Cannot be formed as wires. Now, they are not good conductors of heat and electricity. Okay, so they do not allow heat or electricity to pass through it. Okay, so non-metals are what? They are not lustrous like metals. Non-metals are generally soft. Now, name a metal which is soft. You'll say, yes, ma'am, the metal which is soft can be what? It can be, say, sodium, which is denoted by Na, potassium, which is denoted by K. They are soft metals. Okay, so non-metals are soft. They are non-lustrous. They are not having that shine in it. Okay, diamond is an allotropic form of carbon, and it's very hard, and it's the hardest naturally occurring substance. Non-metals are having low tensile strength. That means they cannot hold weight. Okay, graphite is a non-metal which is at all not strong. It has very low tensile strength. Okay, you know what? Graphite and diamond, they are the allotropic forms of carbon. You know that the properties of graphite and diamond are different on account of the structure and arrangement of the molecules. In case of diamond, it's very hard, and rather it's considered to be the hardest substance. Why? Because of its structure. It has a network like structure, or it has a cage like structure. Now why? Because each carbon atom in diamond is tetrahedrally linked to another carbon atoms. They are all tetrahedrally linked to another carbon atoms, and it is forming a cage like structure, a network like structure. It's having close packing. But in case of graphite, it has layer like structure, as if one layer of graphite carbon layers is slip past another layer. Okay, so it is as if it is having layers over layers, and it is passing one layer over the other. Now, in case of graphite, one carbon atom is linked with three carbon atoms, directly linked with three carbon atoms and not four. So the fourth valency of carbon is free. That gives the conducting nature to graphite. So someone can ask you that graphite is a non-metal, but yet it is acting as an electrode. Okay, so we can see it is a good conductor of electricity. Graphite is a good conductor of electricity. Why it is a good conductor? Because of this reason, that each carbon in graphite is covalently bonded to three other carbon, and carbon has a valency of 4. It can form 4 bonds. The fourth bond is free over here. That causes the conducting nature. And how is the structure of graphite? It has a layer like structure, whereas in diamond it has a cage like structure. It's a network like structure, and so it's very, very hard, close packed structure. Non-metals can be solid, liquid, or gases at room temperature, like carbon, sulfur, and phosphorus. They are solid. Bromine is liquid. Hydrogen, oxygen, nitrogen, or chlorine, they are non-metals which are gaseous in nature. So what did I say? I said non-metals can be solid, can be liquid, can be gases. Now solid non-metals, what are they? Solid nonmetals can be carbon, can be sulfur, can be phosphorus. Now liquid nonmetal is bromine. Okay, so bromine is a liquid nonmetal. Gaseous forms are oxygen, it can be nitrogen, carbon, it's chlorine, or it can be hydrogen. Okay, so these are gaseous. Okay, nitrogen, or these are the elemental forms. So these are gaseous in nature. Now, non-metals have comparatively low melting points and boiling points, except again graphite. Graphite is an exception. It has very high melting point. Why? This means that non-metals melt and vaporize at a low temperature. That's why it has a low melting point and it can vaporize easily. Now, graphite is the only non-metal which has high melting point, and see the melting point. It's 3700 degrees Celsius. Okay. And the reason behind it is the structure of graphite. Okay. So the non-metals have low densities. Okay. They have low density, and so they are light substances. Okay. So next is non-metals do not make sound. No, so they are non-sonorous. They have different colors. So here non-metals, we can see carbon is one of the most important non-metal, because all life on earth is based on carbon compounds. So all organic compounds based on living things, they are all made up of carbon. So carbon forms majority of the compounds. Another non-metal which is very essential is oxygen, and it's equally important because the presence of oxygen is the cause of life. We can breathe because of this oxygen. It is also necessary for the purpose of combustion or burning. Okay, so these are the differences, or I'll say the comparison between metals and non-metals based on their properties. Okay, now this is some question. State two reason for believing that copper is a metal, sulfur is a non-metal. Nothing. You just have to give the properties related to metal, properties related to non-metal for copper and sulfur respectively. Now, metalloid means it contains both the properties of metals as well as non-metals, or rather I will say it has some properties of metals and some properties of non-metals. Silicon, germanium, boron, antimony, these all are considered to be metalloids. Okay, now when I was talking about periodic table, I said that in a periodic table, if I remain towards the left side, they are basically metals. Towards the right side in a periodic table, they are non-metals. And in between, in a zigzag manner, they are metalloids, and they possess properties pertaining to metals as well as non-metals. If they are little bit towards left, they will possess more of metallic character than non-metallic character, and if they are little more towards right, they will possess more of non-metallic character than the metallic character. So next, moving on to mixture. Mixture means you mix too many things together, right? It does not contain one type of substance. It consists of two or more elements or compounds, not chemically combined together. Air is a mixture of gases. It contains many gases in it. Okay, so various gases are present in air. Now, alloys, they are also mixture. Like all the solutions are mixture. Salt solution, sugar solution, they are all mixtures. Okay, now here we can see milk here is a mixture. Why? Because it contains water, fat, protein, sugar, minerals and vitamins in it. So it is also a mixture. Okay, so next, Moving on to the next page, here we see there are types of mixtures like homogeneous and heterogeneous. As already I mentioned, homogeneous means containing same types of substances, containing uniform composition throughout, and heterogeneous means containing different types of substances, containing non-uniform composition throughout. Okay, so these are the essential difference between homogeneous and heterogeneous substances. Okay, so here we can see examples of heterogeneous mixtures are sugar and sand mixture, salt and sand mixtures. Then we can see gunpowder, milk. These are all examples of ink. These are all examples of mixtures. Okay. Iron filings and sulfur mixed together. It will form mixture. Now, most of these mixtures are heterogeneous. Only solutions and alloys are homogeneous. So, solutions and here we can see a mixture of iron and sulfur is taken. Can you separate? If I take, say, a mixture of iron and sulfur. Okay, say I have taken iron and I have taken sulfur. Okay, now how can I separate these mixtures? How can I separate them? Two types of substances are there. Now, iron is attracted to magnet. So I can use magnetic method of separation. Iron will be attracted to magnet and sulfur will be left behind. Or I can use the solubility property. Sulfur dissolves in carbon disulfide. So we can either use a magnetic separation to separate iron and sulfur, or we can use the solubility, that is carbon disulfide. Sulfur dissolves in it, organic liquid carbon disulfide. So you will see sulfur getting dissolved. So iron will be remaining. So you filter it. So what we can do is, to separate iron, number one, we can use a magnetic separation method. Then it's a physical method, okay? Magnetic separation. Or we can use a chemical method where we can use the solubility property of say sulfur in carbon disulfide. Once it becomes soluble, we can again now filter it. When we filter it, we will obtain what? Suppose we are filtering it and then we'll see iron is remaining behind, and in the filtrate part, what we have is what? The filtrate part has the solution. What solution? Sulfur dissolved in carbon disulfide. Okay. Now the filtrate will be having sulfur dissolved in carbon disulfide. Now what you can do is follow the method of evaporation to remove the solvent and to obtain the sulfur particles. So from these experiments we can conclude that mixture can be separated into its constituents by physical process, and these are the physical processes: filtration, evaporation, sublimation, distillation, magnetic separation. These all are physical properties or physical processes. Why? Because we can physically remove one component from the other. We can remove the constituents by physical methods. Okay. So this is one of the example. So next we can see compounds. What are compounds? Okay. Compound is a substance made up of two or more elements chemically combined in a fixed proportion by mass. Suppose I say water. Water is H2O. There are two elements, hydrogen and oxygen, which are chemically combining, where I can say 2 parts by mass of hydrogen combines with 1 part by mass of oxygen. Okay, so the atomic mass of hydrogen is 1 U. So we can say, as per atomic mass, 2U of hydrogen combines with atomic mass of oxygen 16U, which is coming out to be a simple ratio 1:8, simple whole number ratio. So it is combining in fixed ratio by mass. In the formation of CO2, similarly, carbon and oxygen combines in C:O, that is 1:2 parts by mass. Now, what is the atomic mass of carbon? It is 12U. So 12U is to 2 into 16U. So what can we say? Here we can say this 2 and this is 6. So this is 3 and this is 8. This comes out to be 3:8, which is a simple whole number ratio. So fixed proportion by mass. The elements are combining in order to form compounds. To study the properties of compounds of iron and sulfur, this is what we have seen, that iron is getting attracted towards magnet. It can be removed by physical methods. Sulfur was also capable of getting removed by physical methods. But if I make this iron and sulfur chemically react, it forms a black compound which is known as iron sulfide. This is a compound which is black in color. And now in the iron sulfide, it does not contain the properties of iron. It does not contain the properties of sulfur separately, but the property is of iron sulfide solely. It's a different property. So a compound cannot be separated into its components by physical method. Now if I say from this iron sulfide compound, you separate iron and sulfur, you will say no ma'am, it's not possible. The compound to this iron sulfide compound, say iron sulfide stick I have. So these FeS stick, you bring a magnet close to it, you will see it's not getting attracted towards the magnet. You dissolve this iron sulfide, try to dissolve it rather in carbon disulfide. You will say, no ma'am, it's not getting dissolved. So why? Because it is not possessing the properties solely of iron or solely of sulfur. Okay, so iron sulfide compound is prepared by heating together iron and sulfur. Once the reaction is complete, it does not contain the properties of iron and sulfur separately, but it is having a combination of Fe and S chemically, where Fe is to S has a 56U is to 32U ratio by mass of atoms, which is 7:4, which is a simple whole number ratio. So FeS is a compound having a fixed or a definite formula, a fixed proportion by mass of Fe and S, and it has a fixed melting point and boiling point. All other properties of compound is possessed. So next we move on to the difference between mixtures and compounds. Okay, so this is the mixture, difference between mixtures and compounds. Though a compound is homogeneous, a mixture may be homogeneous or heterogeneous. Okay, so here we can see very important points of differences. This is a sample problem. Explain why air is considered to be a mixture and not a compound. Air contains various gases in it. It contains various constituents in it. So it is a mixture. That is one. Now air shows the properties of all the gases. Each gas have different properties. Heat and light, etc., can neither be given out nor absorbed when it is prepared by mixing all the gases together. I can physically mix the gases and form air of any composition, right? So we can say air is a mixture and not a compound. Another one, explain why water is a compound but it is not a mixture. Water is what? It is H2O. This we have discussed. H2O containing fixed proportion by mass 1:8 by mass of hydrogen is to oxygen, where the properties of hydrogen and oxygen are separately not there, but the property is of H2O as a whole. So it has a fixed boiling point 100 degrees Celsius. Okay. Now water cannot be separated into its constituents. That is what I said. Now classify these things into elements, compounds and mixtures. This is something which is very important. So you can just see this example. Now give the names of the elements present in the following compounds. Quicklime, hydrogen bromide. You need to know what is quicklime. Quicklime is CaO. Slaked lime is CaOH whole twice. Lime water is what? CaOH whole twice. And then limestone is CaCO3. So this is what I said. I said CaO is quicklime. I said CaOH whole twice is slaked lime. It is also known as lime water. CaCO3 is marble, or it is also known as limestone. Okay. So these are the things. The elements present are quicklime may calcium and oxygen. In case of slaked lime, calcium, oxygen, hydrogen. In case of limestone, or say in case of marble, it is also known as marble. What it contains is calcium, carbon and oxygen. The case of solutions, here we can see solutions. Salt solution is considered to be a mixture because of the reason what? You can separate salt and water by physical process. That is, you can separate it by distillation. You can separate it by vaporization also, evaporating to dryness. Salt solution, there you can separate both the constituents by evaporation to dryness, by distillation method. So it's considered to be a mixture. Okay, the liquid which evaporates completely leaving no residue is a pure substance. It's a pure compound. The liquid which leaves behind a residue on evaporation is considered to be a mixture. So this is what about mixtures, compounds. But what about alloys? What are alloys? They are homogeneous mixture of metals. So alloy is also a mixture. What type of mixture? Homogeneous mixture. Why is it homogeneous? Because it contains uniform composition throughout, and it contains metals in it, not non-metals. Okay. Mostly metals in it. Now, even then, an alloy is considered to be a mixture. Why? Because of these properties. It shows the properties of variable composition. For example, brass is a homogeneous substance. Now, brass is an alloy. Okay, brass is an alloy. Now, an alloy is a homogeneous mixture. Okay, it's a homogeneous mixture. An alloy is a homogeneous mixture. What does brass contain? It contains copper, it contains zinc in it. Okay, so what are the metals that form brass? Copper and zinc. And they, of course, cannot be separated from brass. Now, that means it has lost the properties of copper, it has lost the properties of zinc, and so it is considered to be a mixture. It's considered to be a mixture because it has variable composition.